Hello students, today we're going to be talking about segments and we're going to introduce the idea of what congruence means. Please don't forget to take notes as you go and complete the survey that follows this video. So before we get into things, I want you to understand what a postulate or theorem is. We're going to introduce a couple of them within this video, so I want you to understand what those two words mean. The first is a postulate, or you can also call them axioms, but this is a rule that is accepted without proof. So if I say this is whatever postulate it is, we don't need to prove anything about it. However, it's a theorem, it's a rule that can be proved. So let's think about you're on a freshwater fishing trip and you catch the fish that's below. By law, you must release any fish between 15 and 19 inches long. You need to measure your fish, but the front of the roller on the boat is worn away. Can we keep this fish? Well, if we think about this, by placing this fish on the ruler, we don't have to place it at number 1. We can place it later on, because everything, this is kind of like a line segment. We can shift it down on the number line and still determine what it is. So let's say the head of the fish is at 4 inches. Well, we want to know where the tail of the fish is. Looking on here, it looks like it's sitting at 16. So if we can determine what the thing is, how long is this fish given this information, yeah, we can easily just determine it. We'd have to take 16, we can subtract off 4, and we see that our fish here is in fact 12 inches long. So based upon this, we can't keep our fish. So our first postulate is the ruler postulate, and that's what we used in our previous situation. Every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and real numbers. The real number that corresponds to a point is called a coordinate. So if we're looking at a number line, we can easily find, if we took this line segment here and we put it up against a number line or a ruler, we can easily find its distance. We find the distance by taking the value of A. Again, it doesn't matter, we can have these switched. The value of A and subtracting off B, and then as you can see here, we have absolute value bars. And the big thing here to remember is that distance can never be negative. So from A to B, if we were to subtract, we take the absolute value. What we tend to do is when I ask for the distance, if you see on the left or here on the right, if I ask for the distance AB, I don't put any kind of line or any symbol there. So if I say find AB without any lines on top of it indicating line segment, that means I'm asking you to find a distance. We can take our values here and we can add them together. There are two scenarios to consider when discussing segment addition. You need to know how to solve for a piece or solve for the whole thing. So let's look at the following examples. Our first one, visualize at Oldham County High School. The distance from the lunchroom to the library is approximately 30 feet. The distance from the library to the gym is approximately 50 feet. If you were walking from the lunchroom to the gym, about how many feet would you be going? So this would be one type of situation we'd be doing with segment addition. And the other type would be the distance from the main office to the band and choir room is 60 feet. The distance from the main office to the guidance office is 75 feet. How far are the band and choir rooms from the guidance office? So looking at the top scenario versus the bottom scenario, in the top one, I'm giving you the distances between the two things, and to find the whole length, we would add them up. But if you look at the second one, I am missing a portion of my segment, and that's what I'm actually trying to find out. So I actually would use subtraction in that problem. So what we have is our segment addition postulate. And what this says is if B is between A and C, then I can find the lengths of AB and find the length of BC, and I can add them together to get the whole length of AC. If AB and BC is equal to AC, then we also know that B has to be in between A and C. So now I want you to understand the difference between when I say something is equal versus congruent. We use the value as equals when we're discussing an actual measurement. So for example, if I'm looking for the length of a segment, such as what we were doing a moment ago, and we're using units of measurement like feet and so on and so forth, that would be a equal sign. If we're looking for the measure of angle, so we're looking at degrees, that would also be an equal sign. And we always use units such as inches, degrees, etc. The symbol that we use is what you're used to. An equal sign looks just like that. However, we will discuss when things are congruent. So we do that when we're discussing a relationship between lines, angles, or shapes. So for example, if I know the lengths are equal, then I can say that the two lines are congruent. Again, I'm not discussing what the lengths actually are, but since I know that the lengths are the same, that if I were to discuss the relationship between the two lines that I'm discussing here, then I know that these are congruent. Same idea with angles. I know the degrees of different angles, that they are equal, therefore the angles themselves are congruent. The symbol we use is a little bit different than the equal sign. If you take a look here, Okay, we have this squiggle sitting on top, and that always implies that it is congruent. If you have any questions, now is the time to write them down or submit them in the survey. Please make sure you bring them tomorrow if you so wish, and don't forget to complete the survey tomorrow. By tomorrow. Have a great day.